The desire to create life from non-living things is a story as old as humanity itself. It's a deep and persistent yearning, woven into our earliest myths and legends. Long before the circuit board, storytellers imagined beings crafted from clay, wood, metal, given motion by gods or magic. In Greek myth, Hephaestus forged golden handmaidens, not statues, thinking, moving servants of gleaming metal. This ancient dream planted the first seed of robotics. It wasn't only myth. Across the ancient world, inventors tried to make it real. In Alexandria, minds like Hero made contraptions that mimicked life. He built birds that sang as water flowed through them. He made automatic temple doors that opened by steam. Steam rose from a sacrificial fire. Simple mechanisms by today's standards, but revolutionary then. They used pneumatics and hydraulics to create the illusion of independent action. These automatons inspired awe. They featured in religious ceremonies. They entertained royalty. Their inner workings were closely guarded secrets. Imagine a bronze statue pouring wine on its own, a miracle to ancient eyes. That wonder still drives robotics today. For many centuries, the dream of the automaton lay sleeping, a curiosity of a bygone era. But then, in the workshops of medieval and Renaissance Europe, a new kind of magic began to take hold. This was the magic of the clockmaker. These artisans, with their extraordinary patience and precision, gears, springs, escapements, they were learning to capture and measure time itself, creating intricate machines that ticked with a steady, predictable rhythm. It was this mastery over complex mechanical systems that would rekindle the ancient ambition of creating artificial life with a new level of sophistication and artistry the world had never before seen. Celestial clocks, ornate timepieces, were soon applied to more whimsical, lifelike creations. The automaton was reborn, not powered by steam or water, but by the tightly wound energy of a spring, released with the controlled precision of clockwork. In the 18th century, inventors like Jacques de Vaucanson and the Jacquet-Droz family became celebrities for their astonishing mechanical figures. Vaucanson's digesting duck, a marvel of copper, could flap its wings, crane its neck, eat grain from a person's hand, and via a hidden compartment even appear to digest it. The gentle ticking of the clockwork automaton was soon to be drowned out the roar of the steam engine. The Industrial Revolution began to gather pace in the late 18th century. It wasn't about lifelike figures for entertainment. It was about harnessing immense power to do work on a scale never before imagined. This era was driven by a new kind of thinking, one focused on efficiency, productivity, mass production. The artisanal clockmaker gave way to robust engineering needed to drive looms. Pumps, presses, automation moved from the drawing room to the factory floor. The key innovation? Break complex tasks into simple, repeatable steps. One brilliant example was the Jacquard loom, invented in 1804. This remarkable machine used a series of punched cards to control the weaving of intricate patterns. Each hole on the card corresponded to an action the loom should take, such as lifting a specific thread. By stringing these cards together in a sequence, the loom could automatically produce complex designs that once required an incredibly skilled weaver. This was a revolutionary concept, a machine that could be programmed to follow instructions. A direct ancestor of modern computer-controlled robotics. This period saw machines that performed tasks with strength and stamina far beyond any human. Steam hammers could forge metal with titanic force, while automatic spinning mules could produce thread at a breathtaking rate. As the 20th century dawned, the raw power of the industrial age began to be refined. The focus shifted from simply building powerful machines to creating entire systems of production that worked together seamlessly. The most significant leap forward came with the introduction of the moving assembly line, famously perfected by Henry Ford for the production of his Model T car. Instead of workers moving around a stationary object, the object itself moved past a series of stationary workers, each performing a single, specialized task. This broke down the complex process of building a car into hundreds of simple, repeatable actions, dramatically increasing speed and efficiency. The assembly line was, in essence, a human-powered robotic system. Each person acted as a component, a biological machine programmed to perform a specific function repeatedly. It was a marvel of logistical engineering, but it also highlighted the repetitive, dehumanizing nature of such labor. That environment created the perfect opportunity for the next evolution, the introduction of true automation. The goal was to replace human components with machines that could perform the same simple, repetitive tasks tirelessly and precisely. This was the birth of the industrial robot as we know it. The first true industrial robot was named Unimate. Installed in a General Motors factory in 1961, it was a hydraulic arm tasked with lifting and stacking red-hot pieces of die-cast metal. Unimate could work where humans couldn't, never tiring, never complaining, never making a mistake. It followed a step-by-step program stored on a magnetic drum. Unimate's success was a landmark. While engineers were busy building the real-world ancestors of robots in factories, another kind of robot was being born in the imaginations of writers and filmmakers. It was in the world of fiction, particularly in the burgeoning art form of cinema, that the public truly met the robot for the first time. The very word robot itself did not come from a laboratory, but from a 1920 play by the Czech writer Karel Čapek, titled Rur Rosum's Universal Robots. In his story, these artificial workers rise up against their human masters, a theme that would resonate through science fiction for the next century and beyond. The silver screen gave these ideas a visual form, shaping our hopes and fears about this emerging technology. One of the earliest and most iconic cinematic robots was the beautiful but sinister Maria in Fritz Lang's 1927 masterpiece Metropolis. This gleaming metal automaton, a Mensch or machine human, was created to sow chaos among the working class. She was a powerful symbol of how technology could be used to manipulate and deceive, planting a seed of anxiety in the public consciousness. For many, Maria was their first glimpse of a humanoid robot. She was both captivating and terrifying, a duality that would define our cultural relationship with robots. As the decades passed, cinema introduced us to a whole menagerie of mechanical beings. There were the menacing, world-destroying robots of 1950s B-movies, like Gort from The Day the Earth Stood Still. But there were also friendly, helpful robots. Rosie, the Jetsons' maid, represented a future where automation would free us from domestic chores. Perhaps no film characters did more to humanize robots than R2-D2 and C-3PO. They became central characters with distinct personalities. For decades, the evolution of robotics was primarily a story of mechanical engineering. The robots in factories were strong and precise, but they were also fundamentally unintelligent. They were powerful arms, but they lacked a brain. That all began to change with the invention of the microprocessor in the 1970s. This tiny silicon chip, containing an entire computer, was the digital spark that would ignite a new revolution in robotics. It meant that complex control systems, which once required massive cabinets of electronics, could now be placed inside the robot itself. The steel body was about to be united with a silicon brain. This fusion of computing and mechanics opened up a universe of new possibilities. Robots could now be programmed with far more complex languages and could process information from their environment. The development of sensors, electronic eyes and ears, allowed a robot to see and feel the world around it for the first time. A robot arm was no longer limited to moving between pre-programmed points in space. It could now be equipped with a camera to identify an object, calculate its position, and adjust its own movements in real time to pick it up. This was a monumental leap from simply repeating a task to intelligently interacting with the world. This new era saw the birth of artificial intelligence, or AI, as a driving force in robotics research. Scientists and engineers began to develop software that allowed robots to learn from experience, to solve problems, and to make decisions. Researchers built robots like Shaky at Stanford University in the late 1960s and early 1970s. Shaky was a wheeled platform equipped with a camera and touch sensors, and it could navigate a room full of obstacles by itself. The age of the truly smart robot had begun. With their newfound digital intelligence, robots were ready to leave the predictable confines of the factory and venture into realms previously accessible only to humans, and sometimes not even to them. Two frontiers became showcases: the vast hostile emptiness of outer space, the microscopic delicate landscape of the human body. These environments, dangerous or physically impossible for humans, were perfect proving grounds. Space exploration is one of humanity's grandest adventures, largely experienced through our robotic emissaries. Beginning with the Lunokhod rovers on the Moon, we sent machines as our proxies across the solar system. Sojourner Spirit Opportunity. These robots aren't just remote-controlled vehicles, they're semi-autonomous geologists, navigating treacherous terrain, analyzing soil samples, making limited decisions to survive millions of miles from home. Closer to Earth, robotic arms in orbit. The Canadarm2 on the International Space Station. They can move massive modules into place, capture satellites, and provide a stable platform for spacewalks. Back on Earth, robotic arms entered the operating room. Surgical robots like the Da Vinci system allow surgeons to perform incredibly complex procedures with superhuman precision. The robot translates movements into steady, tremor-free actions inside the body, enabling minimally invasive surgery with smaller incisions, less pain, and faster recovery times. For most of history, robots were confined to specialized domains: the factory, the laboratory, or the distant plains of Mars. They were large, expensive, and complex machines, far removed from our daily lives. But in the 21st century, that began to change. As technology became smaller, cheaper, and more powerful, the robots started to cross the threshold of our own homes. This new wave of domestic robots was not designed for heavy industrial tasks, but for the everyday chores of cleaning, entertaining, and assisting. The robotic companion long imagined in science fiction was finally becoming a reality. The first domestic robot to achieve widespread success was the robotic vacuum cleaner. Introduced in the early 2000s, devices like the Roomba were a marvel of consumer-level robotics. They combined simple navigation algorithms, an array of sensors to detect walls and stairs, and a clear, useful purpose: to clean our floors while we were busy with other things. Its success proved there was a public appetite for robots that could help around the house. Beyond cleaning, robots are beginning to take on roles as companions and assistants. We see this in the form of social robots designed to interact with people, particularly children and the elderly. Robots like Paro reduce stress and improve mood in patients in hospitals and care facilities. We stand today at a remarkable moment in the long story of robotics. The ancient dream of creating artificial life has led us on an incredible journey. From mythical golden servants to ticking clockwork figures to intelligent autonomous machines that explore distant planets and assist us in our own homes, we have moved from simple automation that mimics action to advanced robotics that incorporates learning and decision-making. The robot is no longer just a fantasy or a factory tool. It is a burgeoning presence in our world, and its evolution is accelerating at a breathtaking pace. What then does the next horizon look like? The future of robotics will almost certainly be defined by ever deeper integration with artificial intelligence. The robots of tomorrow will be more than just programmable. They will be adaptable learners. They will be able to understand natural language, learn new tasks simply by watching a human, and collaborate with us in complex and dynamic ways. We are seeing the beginnings of this in fields like logistics and in agriculture, where they can identify and harvest individual fruits. This shift from automation to true autonomy will allow robots to tackle problems that are currently far too complex for machines. We can also expect robots to become more physically adept and versatile, inspired by the natural world. Others are perfecting legged robots and collaborative machines that work safely alongside people. Ultimately, the future of robotics is a story of partnership.